I think I'm the first one that was introduced 3 times already. Thank you very much for this introduction. I work at the university, and the story I will tell you today actually started during the Top 500 program, because I had the opportunity to be in Cisco Wireless Unit, and that was the place that had a number of advantages. First, it was unlimited coffee, and the second was ability to access any meeting that was taking place in Cisco. And together with a friend, we went to a meeting where people were talking about using Wi-Fi for localization people on the airport. And that's how it started. So it actually started in Silicon Valley. I work at the University of Wrocław in a group which is focused on computer architecture and embedded systems. And because we work at the university, we do research, but we also try to do lots of proof of concept solutions. So this is what we are focused on, and the proof of concept solutions are within embedded system, Internet of Things. We do hardware prototyping and application prototyping. We stay quite closely linked to the industry, as already Krzysztof said. As a university, we are a member of DAF7 Alliance. That's another radio technology that is quite promising for future Internet of Things application. And we focus on 3 main areas. So first of all is low power radio networks, indoor and outdoor localization. Actually, we started with indoor localization as we were visiting Cisco, and then network and system security. Indoor localization is very interesting from my point of view, because there are lots of challenges. That's why it is very interesting for research. But there are also a number of applications where you can use information about where people or assets are. I will talk about it on the next slide. But unfortunately, there are lots of constraints that prevent of using the traditional technologies or limit the use of traditional technologies like Wi-Fi and Bluetooth. I said that Cisco was using Bluetooth for localization of people, and this is very commonly used in shops, for example, for tracing how people commute in shop or in the airport. Airports sell the price of a square meter at the airport. Cost depends on how many people walks along this area. So that's very important information for airports, because they earn on this information. When we start to work with this topic, we focus on 2 technologies which are dedicated technologies. One is UVB and the other one is CCS. Those 2 technologies are very accurate in localization. UVB can localize elements with precision of single centimeters, which is not possible for Wi-Fi or Bluetooth. LoRa and Dash7, since they are dedicated for outdoor application, long-range application, will never be as accurate. But according to what developers of LoRa say, they hope that finally we will be able to have 50 meters accuracy with a dedicated hardware and software. We also work on algorithms. It's not so easy as it may seem to localize device or person if you have measurements. So from the measurements to the actual location and making sure that you are quite accurate in the location estimated, it's not so easy, and that's quite a challenging task. Application, retail and airport, that's the thing that is going on around, also in Poland. Number of shops are using Wi-Fi sniffers to know whether people come back to the shop, how they walk in the shop. They are even interested in what things we touch in a shop, and the most important thing is what we have taken from the shelf but have not bought, because it means that we are interested in something, but for some reason we decided not to buy it at the end. So this allows the shops to target the advertisement and approach clients individually. Another application which is very interesting is safety, especially for the underground mines. I don't know if you are aware, but the first reason for casualties in underground mines in Poland is fire and methane explosions. But the second, third, and fourth are the facts that people are in the places where they shouldn't be. The issue is that we cannot localize right now people accurately underground. In Poland, there are some areas underground where fixed number of persons can be at the same time. But these are large areas of several hundred meters. We don't know where people are. And if accident happens, we don't know where people were just before the accident happened. So we don't know where to look for them. Geofencing is another interesting application that was mentioned by Krzysztof, so I will just skip it. What we have done? We have done several hardware prototypes. The first we done was actually a tracker for underground mines. This was done together with a company from Wrocław, which is called Silesia. They do software and hardware for underground mines for communication. And we did, this is the photo in the upper right corner. So we did a prototype device that actually works and can localize people underground. We also developed a smaller token which was dedicated for tracking people. We use it for tests, and we had experiments. We conducted experiments for using accurate localization, using UVD technology, for locating people during the workout. So as they train, as they run, we wanted to trace how they run and trace how they perform in exercise. And we did this together with Wrocław football team because they want to know what are your physical capabilities. And there are solutions that you can buy, but they use GPS, so they don't work indoor. And if you train indoor, you don't have a solution. We do lots of simulation and tests. We have several times went underground to test the device for localization of people and assets in mines. And we work quite a lot on algorithms, because as I said, it seems very easy to find a position having measurement, but in fact it is not. There are a number of factors that influence the accuracy of the final position, and this is not so trivial as it may seem. We have partnership with Dash7. We are actually a member of Dash7 Alliance. We have a colleague of mine is a member of a board of directors of Dash7, so we have our representative there. We cooperate with University of Environmental and Life Science. We did installation for horticulture for glass houses for university to measure the conditions inside the glass houses as during the crops were grown there. We also cooperate with University of Antwerp and City of Wrocław in developing different proof of concept solution for the smart cities. Thank you very much for your attention. I would be glad to answer any questions if there are any.